Hello, and this is the last of Camp's C++ quickies in the uh, array vector pointer series. Okay, the messing around with blocks of memory series, I guess you could call it. And today we're going to talk about pointers. Now, pointers are a concept that exists in C and C++. There is no equivalent to a pointer in Java, and that is on purpose. They believed that pointers were not safe enough for Java programming. Um, you can use pointers in C Sharp, but you have to declare the code to be an unsafe block of code or an unmanaged block of code before you can use them. So they're of fairly limited use in C Sharp. Um, so we're going to talk about pointers here um, as they appear in C and C++. Okay. Um, so a pointer, um, so far what we've learned is that um, if we create int num, that variable points to a memory box that maybe contains the number 1023. Okay? You can also create a pointer, int star num pointer, that points to this variable, which points to that number. Okay? Another way of putting it is this block of memory here has an address. Maybe it's A134, or it looks like a 9, so we'll call it A139. And the next block is A140. Okay, and the next block is A141, and so forth and so on. Actually, we're doing hexadecimal here, so it doesn't quite work like that. This would be A131, then that would be A132 and A133, but we'd eventually get to a point where we'd have A130A, then A130B, and memory addresses are usually reported in hexadecimal codes. So int num pointer technically does not actually point to num. This is not quite correct. Int num pointer points to a memory box that holds the value A131. And then that memory box points kind of indirectly to the value held by num. Why would you want to do this? It seems like a fairly silly thing. Well, essentially, you can start building your own arrays. It says 1023 and 1046 and 1072. If I wanted num pointer to point to the next number in the series, I just scratch off this and say A132, and now it points here. So it can work kind of like an array, and in fact that's what arrays are, is they're pointers to a series of values. So you can do pointer arithmetic and add to your pointer, subtract from your pointer, move around which memory you're talking about. And that's where pointers really come in handy. The other thing you can do with pointers is you can pass them to functions. If I pass num pointer to my function, say function add 1, and let's say that's weird. Okay, let's say function add 1 took an argument of type star pointer. Okay, um, then I would pass value A132 into star pointer, and this function, when it adds 1, would actually change the value in that memory box. And that way, the function can read values into my memory, can do things, mess with my memory, add 1, subtract 1, um, and it actually changes the memory in the main program, not just the copies of the variables that I have in my function. So that's an interesting other thing you can do with pointers. Finally, the last thing you can do with pointers that's really cool is you can say num pointer equals new int, and that will create a brand new memory box for this to hold stuff in. Now, creating one new integer is not all that special, but I can say new int of num. I can pass it another variable. Okay, so I've just created a variable sized array. Okay, it's not actually variable size, it's fixed size, but the size is determined at runtime. It's determined by whatever value is in that box while I'm running the program when I hit this line of code. Okay, so far we haven't been able to do that. Arrays had to be declared to be a size that the computer knew about before the program ran. So let's see how some of this works in code. So let's say we go back to our example of tracking COVID cases. I can say int star cases, okay, instead of declaring the size of the array up front, I can declare int days in month, okay, and I can see out how many days in this month. Or actually, it doesn't even have to be a whole month. I can just say, how many days do you want to track? Okay, I can see in days. And now I can say cases equals new square bracket days. Now I've created a brand new array that has this many, I have to say new int bracket days. Okay, I've created a new array that's exactly the right size to hold the number of days. I didn't have to declare the array to be 31 members long all ahead of time. I can track 10 days. I can track 45 days if the person wants to track more than a month at a time. Now, what I can't do now is use the range-based for each loop. Okay, I have to use a standard old-fashioned for loop for size I equals 0, I less than days, I plus plus, see out how many cases on day I plus 1. Okay, Cn. But I can do this a couple of different ways. I can use pointer arithmetic. I can actually use the array operator cases at I. Okay. Because I've now created an array and assigned it to the pointer cases, I can do cases at I. I could also say cases plus I, do my pointer arithmetic, and then put a star in front of it to indicate that I'm dereferencing the pointer. Okay. Both achieve the same goal. And then I can do this again. I can print out cases at I, and I'll just show you that they both produce the same result here. The pointer arithmetic version or the array operator version, cases at I, less, cases on day I plus 1, end line, semicolon. Okay. And if we run this, I can say, how many days do you want to track? I want to track 5. There were 10 cases, and then there were 18 cases, and then there were 32 cases, and then there were 65 cases, and then there were 72 cases the next day, and there we go. Okay. If you want to just use the first value that a pointer points to, you can say cout star cases, or you can say star cases equals 101. Okay, and that will change just the area that cases is pointing to, so just that first memory box in the array. Okay. So that's a real brief overview of pointers. You could read much more about pointers and some of the things you can do with them in your textbook or other C++ reference sites. And of course, you can feel free to ask me for more information if you want. But the main way we're going to use them in this class is for dynamically allocated arrays, which is what we just did here. Okay.